which you broke it down and made it well-defined. What you guys just created are called binomial random variables. Now, the probability distribution idea is applied to a random variable. When Max grabs a box of pullets from the store, I don't know what I've got in that box until they grow up and they show me if they're boys or girls. So if you think about it, they're like rolling a die, a 10-sided die. But each one of their dice has 9 G's and 1 B on it. Or 9 C's and an R. 9 chickens and a rooster. And each one, theoretically speaking, is like throwing that 10-sided die and seeing what I get. Every once in a while, you get a rooster. If you think about it this way, I've now bought 8 chickens from High Desert Ranch and Home. As far as I can tell, they were all females. So a less statistically minded person would say, watch out next year when you go back to buy 4 more. Because you're due for a rooster, right? Due, it's due for... Easy! You're those people that wait for the little old lady to stop playing the one-armed bandits too, aren't you? Yeah, get up, Grandma! No, no, no. Due doesn't exist in infinity. So, this idea of a binomial. Do you know why it's called binomial? 2 outcomes. What are the 2 outcomes up here? Boy or girl. Binomial. I actually got into a near fist fight with somebody about that once. Let me get back into that on Wednesday. On Wednesday. First of all, in order to make them binomial, you have to have a fixed number of independent trials. So I told Max to go in and get 4 birds. I did not tell him to go in and fill the box until he couldn't fit any more birds in it. Because knowing my son, he'd come out with 20 and they'd all be dead. So I said, go in and get 4. That's the number of trials, 4. Now I know we built flocks from 1 to 4, but I wanted to work...
4.
4. This many. Go get 4. Go get 4 birds. So, it's 4 chicks. Now, the key word that we cheated a little bit on is independent. We did cheat a little bit because they really weren't independent. The next bird that comes out does depend a little bit on the bird that came out right before her or him. For example, if I pulled a girl out, that means I've now decreased the number of girls in that box. Which means when he goes back in to grab another bird, it's actually down a little tiny bit from 90%, isn't it? But we agreed it's not enough to be worrisome. It's not enough. There are so many birds in that box and he's only pulling 4 out. Not that big a deal. Not that big a deal. Cool? Fair? Good. All right. So that's the first check. And we checked that off pretty good. The next thing is, and you guys already nailed this, 2 mutually exclusive outcomes. If you're a boy, you're not a girl, and if you're a girl, you're not a boy. This is where I almost got in a fist fight with a student. I read somewhere that 1 in 10,000 pullets are actually both a boy and a girl. And you know what? I've read the exact same thing. I have. And I reran the numbers with that trinomial versus a binomial, and it barely changes anything because it happens so it's 1 in 10,000. It happens so infrequently, it doesn't change the numbers of what usually happens very much. In 105 today, somebody threw a penny up and it landed on its edge. And I said, that's totally badass. That's the first time in 20 years that's happened. And totally badass. And she's like, what are you going to do? I'm like, nothing. I'm like, flip again. She's like, you're going to ignore this? I'm like, no. Took a picture of it. And that's it. I mean, then we throw it away because it's a weird random fluke. We don't rewrite the history books because of that. We make a note of it in the liner and say, yes, it happened 1 in a million trials, and we treat it like an outlier that it is. It's a random fluke. It can happen every once in a while. Fair? All right. Boom. Chasing nothing out. And the last bit is the probabilities don't change. And technically speaking, this is kind of a throwback to numbers 1 and 2. But the idea is we keep reusing the 90-10, 90-10, 90-10. Now, past the point, we will not be able to do that. If it gets going too far, we will not be able to do that because we're going to break the 90-10 and it will get too far away. But if you're taking very small samples from a very large population, you can go ahead and assume that that 90-10 is going to be valid. I'm going to have this linked for you guys after class today, so you guys will have this PowerPoint, of course. Now, you guys did freaking amazing work today, as you guys always do. I love going through these flocks one by one, because it takes some time to develop those coefficients. and to develop the probabilities. But at the end of the day, honestly, it's tedious. If the flocks get too big, this gets ridiculous. So I wrote a program that I want to share with you guys. I want to show you how it works first.